that are helpful. Like you should be able to recreate this diagram on your own scratchboard, and then you can answer questions like these sometimes, always, never questions. And they're in your book on page
22.
I think, what was it, 36? I said there were sample problems like this. So we can reference that in a minute. But your choices of quadrilaterals, you have rectangles, and then rhombuses. What else?
Squares.
Right, squares. What else? Right. Trapezoids. Parallelograms. We're only looking at quadrilaterals. And then I think that we didn't do kites. So I'm going to put kites here. And ignore kites right now. We'll get to them, but they're not in this unit. So if I can just kind of shrink these up, we want to be able to place them in the right places. So who wants to come do this? So you gotta put them where they belong. Okay, come on, Lisa, you start. Start with two of them, and then Caroline, you can agree or disagree and move them. Okay, your turn, Caroline. Yeah, if you agree, come up and keep going. If you disagree, move things around. Okay, and Joe, if you agree, leave them. If you disagree, move them around and tell us why. So it looks like everybody, that group agrees. That's one correct solution. Things that could be different is rectangles could be here and rhombuses could be there. But that's it. That's the solution. Well, kite I fixed, right? So if I lock in kite here, keep it there because we haven't really talked about kites, then balance, there's no options. Trapezoid has to be out here. So this diagram would say a trapezoid is a quadrilateral because it's in the quadrilateral diagram, but it's not a parallelogram ever because there's no overlap. Does that make sense? So like I could say that a parallelogram is a rhombus sometimes. Because some of these, because there are parallelograms that are rhombuses. So we would say a parallelogram is a rhombus sometime. Not always, just sometimes. Okay, Molly, what would you say about a square? A square, how would you describe that? A square is a, is that always true, you guys?
Yes.
Always. Okay, Grace, give me another one. A square is a hardwood. Or hardwood. Is that always true?
Yes.
It's always true because this little square section is completely encased in the rectangle oval. So a square is always a rectangle. But, Grace Waidstein, what about a rectangle? Could a rectangle be a square? Never? So if a rectangle has all equal sides, would you say it's a square? Then we'd say a rectangle is sometimes a square.
Yeah.
You see how to do this? So, Tyson, can a rhombus be a square? Sometimes, right? A rhombus with right angles is a square. Okay. So, can a parallelogram be a square?
Yes.
Always? Sometimes. Can a quadrilateral be a trapezoid? Sometimes. Can a trapezoid be a kite?
I don't know what a kite is.
Never.
Not even knowing what a kite is, since these two areas don't even touch, you would say never. I'm not going to quiz you on that, but that's how you would reach the diagram. So looking down here, circle the best answer. Always, sometimes, or never. Use the diagram above. A parallelogram is a square. So the way I do this is I look at my parallelograms. That's all of these things, right? And sometimes the parallelogram is a square. But not always, because sometimes the parallelogram is a rectangle or a rhombus or just a plain old parallelogram out here. It's not a rectangle or a rhombus. It's just a parallelogram that looks like this, right? So only sometimes is a parallelogram a square, so I would circle this. Okay, Kalis, what about you? A square is a quadrilateral. Always true, right? Because the square is completely encased in the quadrilateral box. Okay, Kyle, how about a rhombus is a rectangle?
Not that well.
Sometimes, good. These are hard. A rectangle is a rhombus, Cole. If it was never the rectangle, and rhombus ovals would be like the kite and trapezoids. They would be completely sometimes, because there's some overlap. Okay, and say a parallelogram is a trapezoid. Never. Raise your hand if that makes sense. Okay, so in your book, I believe it's page 36 in your book. See number 65, the true false?
Okay.
On page 36. So page 36, number 64 and 65 are good problems to think about using this chart. Those are your two homework problems. Yeah. You see under extensions? Yeah. How are we doing on that? See the idea? So like, you should be able to answer questions like that on a test. And sometimes a diagram like this helps you answer questions like that. True, false. Don't do those now because you'll not be able to do the, other questions I have for you to think about. So, I don't know if you heard me, this should have had a degree marker right here. I heard Tyson give at least how many sides the polygon has. What was the answer you had there for number 6? 36 sides, and how do you get that?
Well, since they're with the exterior.
The exterior angle is the key term there.
Exterior angles is always 360 around any polygon.
So the number of sides times 10
minus 2
has to be. Oh, you did it like that.
Oh wait, no. I didn't. Grace kind of came up with you.
Oh, so Grace, what did you do? Maybe I'm jumping the gun. I thought you did this.
Yeah, I was thinking.
That's what I did.
I was thinking the 10, since the exterior angles are always 360.
The sum of the exterior angles always has 360.
It's always 360. So since one exterior angle is 10 degrees, 360 divided by 10 is 36.
Yeah, so something times 10 has to equal 360, which means 360 divided by 10. Here's another one-step problem. N would have to be 36. Can you raise your hand? If that makes sense to you, so I know we can move on. Did everybody come to that one way or another? Okay. There's more than one way to come to that. So I skipped to part B right away. That's a test-taking strategy. I read the whole problem, and then I looked at both parts, and I did the part that was easiest for me. Just because B comes after A doesn't mean that everybody would do it in that order.
I thought
But I think
A was
Tyson
easy.
did part A first because he approached it differently, maybe. Did you, or
Yeah, I did part A first.
you did part A first?
Part A was simple, because for me, all I did was 180 minus 10.
Exactly.
And
So
I get the answer.
some people think part A first, and I just didn't, right? And so what Kyle's saying is he visualized the interior angle to be 170. Is that right?
Yeah.
Yeah. And so that was super easy. I just, for some reason, part B caught my attention first, so I jumped to it because I knew it first. It doesn't mean that I had to do part B after part A. That's my point. Sometimes you do, sometimes you don't. Could I ask you what the sum of all of the angles are?
Yeah.
Yeah. Do I need part A and or part B to do that?
Yeah, I need part A and
You could use part A and B.
But you don't. All you need to know is if how many. You just need to know the equation.
You need to have a method, like, if I'm comfortable with that there's 36 sides, I could use the equation, there'd be 36, take away 2 triangles, right? 34 times 180. So that's one way.
you could do 36 times 170.
That's right. So, and I should get the same answer. So this would be the total sum using the formula. Or if we already know what one angle is, and we know how many sides there are, we can just do 36 times 170. I would get the same answer either way. Does that make sense? Okay. So, missing values here. I realized that maybe this is, you don't have enough background for this. You need to have had that 44 right here.
Well, we were able to figure it out. It was really easy.
Yeah. Well, because 44
Because
is
when
the
two
same.
lines cross, these two angles are always going to be equal.
Yep.
Okay.
The other two are almost.
And the same thing with the 78.
Yeah,
Right.
So
So if you didn't know that, what I'm saying to you guys, if I give you a test question on this, I would probably replace the angles right now because we haven't formalized that rule. If that angle was there,
I did a longer way.
if you had the angles there, could you solve for the missing values?
yes.
Now you should be able to. So, do you see this triangle right here?
I did an extremely long way.
Okay, well look at it that way. Do you see the triangle? Like I dotted 3 vertices right here? Those 3 angles have to add up to how much?
180.
180, good. And we know that 44 plus 30 adds to,
77.
yeah, 74.
And 180 minus
So 180 is equal to 74 plus x. So I can subtract 74 using that algebra from the last unit. So 106 is x. And my x is actually, sorry, I should have said d, right? Let's make those d's. Raise your hand if that makes sense to you, that this is 106 degrees. Yeah? Did you get, okay, hold on to your thought. Did you do it a different way and get the same answer? Okay, Caroline?
It's all.
So did somebody, maybe did you find this angle here first?
Yeah.
Okay, so let's go that way. Let's call that x, since we don't have a letter there. Will we agree that 78 and 30 need to be added to do that? So that's 108, right? And so we know 108 plus something, which we're going to call x, has to add up to 180. Because that makes a triangle right here. Okay, and so subtract 108. And then we have x is 72. That would be right here. And then this makes us a line, right? And a line always has how many degrees? 108. 180. So C has to be 108 because C and X together have to equal 180 because they form a straight angle. And we already know X is 72. So if we subtract 72, we get C is 108. Okay, so far? So now I have new color. Let's see, I have C and I have D, or we haven't, we're trying to find D a different way, right? So you must have then found this angle down here, and that's one what?
I messed up.
That's where your mistake is.
Yeah.
So that's 102. Okay, I'm going to bring in a blank page so we can kind of spread this out. If you did that, and let's just take a quick snapshot of that here and bring it to this page so I can spread it out so you guys can see it. Okay, so if you look at what Caroline was trying to do, she was trying to use the quadrilateral, which does work. So you could have done 102 plus 44 plus 108 plus D, and all of those should add up to 360. And these add up to what?
You get, 254.
54, thank you. So subtract 254. And you get 106. So there's two ways. I think the second way was harder for me. But it might be the way you think of it first, and that means that it's not harder for you to carry, probably.
Can't you subtract the 44 from 180?
Yes, with the 30. That's what I did first. So the question is, did I have to do all that work? And no. I was trying to help Caroline find her mistake. So I did, okay, just a second. I did 44 and 30 together right here. And I subtracted them from that 180 to get the missing value D of 106. That was the quicker way. Kyle?
Never mind.
So the benefit of looking at Caroline's method is that, well, she was able to find her mistake, but you guys can also find a way to check your work by going a second method. It just turned out that method was a little more work on this time. That's okay. We okay there? So going to the next page. Oh, Evan?
Well, for that problem, I just did both triangles.
Yes,
Just did one triangle.
right. There's so many ways to get to the right answer there. Okay, so on the next side, you should have gotten x equals 34. Here.
I
Oh,
didn't really
I got
understand how to do that.
okay, so let's talk about that. Let's make sure I didn't make a mistake. So, do these two angles make a straight angle?
Yeah.
How much does a straight angle add up to?
80.
180. So, then wouldn't it be true 3x plus 4 plus 2x plus 6 has to be equal to 180?
Oh, yeah.
I didn't quite understand what it was asking.
Yeah, me neither.
Yeah.
So find the missing value. That should have been the find the x.
I thought it meant like,
I just thought you were trying to
yeah.
So
same
you
here.
wouldn't make it equal unless you were told they were equal. See how these angles are marked equal?
Yep.
You don't know that. But what you do know, remember if you had a protractor, that they make a straight angle. just in general, a straight line has a measure of 180 degrees. Those are supplementary angles. So that's what you were, the idea of, where is this guy? Thank you, here it is. Okay. So that's a hard problem. So you would add the x's together, right? 3x and 2x makes 5x. 5x plus 4 plus 6 equals 180. This is a challenging problem because there's algebra and geometry. 5x plus 10 equals 180. Subtract 10. You guys understand where I'm going with this? So 5x equals 170. Divide by 5. You get 30. And x equals 30. 5 goes into 7 3 times.
Yep.
There is a remainder of 2. 5 goes into 20 more times. So x equals 34. That's a hard problem.
Wait, don't you have a remainder?
No.
Wait, because,
So that
oh,
ends in a zero.
oh, 17.
Okay. So I'm going to stop there for right now. What I'll do is I'll post this.
Oh, yeah.